non-solid diffusers by electrostatic charging by Deepak, Sahoo, Diego Martinez, Plasencia, and Sriram Subramanian from Bristol University.
Thank you. So this is a short talk, and in this talk I'm going to present how to control non-solid interfaces using fog or mist, such as which are used for making media displays. One example is the fog display, such as the MisTable, where users have individual fog screens reachable to interact with each other and with the tabletop display. Another example is the bubble display, such as SensaBubble, where users are given with multimodal information such as display, visual, and smell. So the main contribution of this talk is a method of how to control fog in the 3D space. Imagine this 3D screen, which is 2D planar, having a 2.5D effect, which changes its shape according to the content or user input, or the bubble display, where bubbles don't just fall down, but we can control their position and trajectory so that we can give individual users with multimodal information. So how do we do it? The main idea is to just charge the fog and use electric fields to control the fog. So we looked at many charging mechanisms, and we realized that the inherent chemical structure of the fog particles is polar. So the nano droplets inside the fog can be imparted with permanent charge, and we can pass them through electric field to control them. So in the paper, we present a charging mechanism where the black lines represent a copper tube, which is ground electrode, and the red line is a copper wire, which is given 4 to 5 kilovolts to create corona discharge, which is the effect happens just before we get spark. So so it ionizes the air inside the tube, and the ions diffuse into the droplets, giving them permanent charge. So the trick is to give them, to have the right mix of ions in the air and charging time so that we get uniform charging. So it's a very simple structure, as you see. We just need a copper tube and a copper wire and some acrylic fixtures and silicone tubing to make the charger. So our prototype is also simple. We take fog from a fog machine and control the speed with which the fog is pushed through the fog charger to get good charging, and then we control the speed through which we make a fog screen by passing the fog through a honeycomb and make the fog screen between transparent electrodes to control its shape, and use a projector to project media onto the fog screen. In case of bubble display, we take the charged fog into a bubble machine that we'll see later. So it all looks good, but there is a problem, that when we pass fog particles through electric field, they need to have uniform electrical mobility, which depends on the size and the charge on them. If we don't have uniform electrical mobility, then different fog particles will move differently, and we'll end up having multiple screens as shown here. So there is a electrical mobility analyzer available, which we use to look at the electrical mobility. For example, in the first case, we see two different kinds of particles, which will require which is usable, but we'll need to make electrical mobility filter, which is also standard to get good performance. So we looked for an easy solution, which will be beneficial to everyone, and we found that we can make a good fog composition which has uniform particle distribution, and also the electrical mobility distribution, as well as which remains uniform after charging, as seen here. So we presented a fog charger to give you a good charged fog with good reliability and high yield. So we use that to do the fast demonstration of a fog screen display, and we see that there is no double screen effect here, and we are able to control the curvature of the fog screen. And because we use transparent electrodes, the content is pretty clear. And so in this prototype, the curvature we got was 12.5 centimeters. So in the second demonstration, we tried to control the trajectory of bubble displays, as we see here. So these are our first results which we reported in the note. And the main HCI, the application in HCI would be that we would like to control the fog morphologies in mid-air, such as the face of a mummy from the popular movie, using charged fog and electric fields, or control the position and trajectory of a bubble, the mid-air display, so that the bubble doesn't fall, but it follows or interacts with the user, and it uses charged fog. So with this, I'd like to conclude my talk, and thank you for listening.
So again, for questions, please come to the microphone. Meanwhile, I do have a question. What do you think if you tile your electrodes? What do you think? What kind of shapes could you create out of that fog?
That's a very good question. According to physics, the fog, when a charged particle moves in a uniform electric field, it has a hyperbolic function. So we'd be able to create different functions of that kind. We would require multiple pairs of electrodes to create different shapes, but it would be of hyperbolic nature.
So maybe a second question, do you think you can levitate bubbles?
Yes, that's the idea, that when I said we could have a floating bubble, could apply electric field in the vertical direction and float it, and provide multimodal information and direct towards users. So we control the position of the bubble as well as trajectory.
Excellent. Thanks a lot.